Okay, continuing on with the quadratic functions. What we're going to talk about in this example is, again, electrical circuits. And in this particular, we're going to talk about resistors in parallel. So we've got this system where we've got two resistors in parallel, meaning that current would be flowing through here. Depending on the values of the resistance, a certain amount would go this way, a certain amount would go that way. We have resistor 1 and resistor 2. And so one of the things that, and then after they've gone through this little part of parallel circuitry, they would come back together and the current would completely recombine and keep going down its path wherever it needed to go. So if it helps, current, well, it doesn't really matter whether it's which direction it's going, but for our purposes, we'll say it's going from left to right. And one of the things we know about resistors in parallel is that to add them together, it is, or at least when there's two of them, it's the product of the two resistors divided by the sum of the two resistors. And so certainly this doesn't seem to fit with our quadratic function yet, but as we see with this particular example, we will see a quadratic function arise. Okay, so for our particular example, we are given that the total resistance is 100 ohms, out to a quite precise number, and that somehow we know that R2 is 4 times R1 plus 100 ohms. And so, of course, what we're asked to figure out is what are the actual values of the resistor 1 and resistor 2. So how would we solve that? So, of course, the place to start is with what we know about parallel circuits, which is the combined resistance follows this pattern, and then just plug in what we know about it and try to solve it. So again, even at this point, it doesn't really look like I'm going to have some sort of quadratic function. So why this is in this unit might be a little confusing. But we go ahead and plug things in. We know that R12 is 100. We don't know anything about R1. We know that R2 is 4 times R1 plus 100, so we plug that in. And now the good news is we have an equation with just one variable in it. The only variable left in here is R1. So we'll try to simplify that a little bit. So if I multiply the factors on top, I get an R squared plus 100 R1. So 4 times R1 squared plus 100 R1. So it's starting to look like something quadratic, but I still have it divided by this factor here. I add an R1 plus 4 R1, I get 5 R1 plus the 100. So I still want to try to separate these things out. So what I'm going to do is multiply both sides of my equations times this factor. And now that I've done that, it really starts to look like a quadratic formula. I need a quadratic. I've got R squared terms, I've got R1 squared terms, I've got R squared, R1 to the first power terms, and I've got some constants. Now I just need to set it equal to 0 so I can actually solve it. So there, if I do my subtraction, I get 4R1 squared minus 400R. That comes from 100 minus 500. Minus, that's 10,000. That comes from, that was 100 times 100 is 10,000. It's now subtracted on this side. So now I've got an equation that I can try to solve. Again, to try to solve it easily, I want to go ahead and divide out I want to divide out common factors. So I've got R1 squared minus 100 R1 minus 2500. Again, factoring is a great thing if I can see one quickly. I would try negative 50, positive 50, but those would actually cancel each other out. 505, that's way far off. So rather than spending a lot of time trying to figure out if there's factors that work, we're just going to go ahead and jump to quadratic formula. So when I use the quadratic formula, again, just to kind of help you out if you're working it, what I get inside the square root is 20,000, so it's a positive number, so we will get solutions. And then as we continue out, I get my two solutions as 120.7 ohms and 20.7 ohms, depending on how far I want to go, negative 20.71 ohms. So immediately I can say that this one does not work because I can't have a negative resistance. So there's only one value that's going to work for me. I just need to worry about that one. And remember, what I'm trying to actually solve is get both values of resistance. So I also need to figure out what R2 is. So the way I would do that is just take my equation for R2, which says that it's 4 times R1 plus 100. Plug the value of 120.71 in there. And so I get, and again, I do not need to worry about that one, just the one. And so that's what I get for my two. For my final answers, I did round to 3 significant figures. And again, Notice there's a big difference in what I say a big difference. There's a small difference in whether I wait till the end to round versus working it all the way and only rounding my final answer. So the fact that I kept that more accurate got me an 8.3 on the end, whereas if I went ahead and rounded to 121, I would have gotten 5.84 on the end. So that would be a chance for you to make a small mistake there to get things wrong. But that's that one. And one of the key points here is just realize, again, because it's an engineering problem, all the solutions you get out from a quadratic formula or for other things are not going to necessarily make sense. You have to always check whether or not your answer is going to work. And then, of course, as always, whenever you get an answer, it's a good idea to plug it back in and make sure it still works. If we plug these back into the original equation, we should get that R12 is 100.